Hello and welcome to Big Data and ArcGIS, an introduction to ArcGIS GeoAnalytics Server. My name is Sarah Ambrose and I'll be presenting with Noah Slocum. This is for the 2020 Esri Developer Summit, which we are doing remotely, so you have this video available to you. All of the links that we talk about, we'll make sure that they are posted with the video so that you don't need to scribble anything down furiously as we go. So what we're going to talk about today is what is GeoAnalytics. We're going to talk briefly what is GeoAnalytics Server versus GeoAnalytics Desktop. This presentation specifically is focused on GeoAnalytics Server, but we do want to touch on what desktop is and why you'd use one or the other. We'll go through the analysis tools, the data integration, so data inputs and outputs that you can use, as well as the system requirements and how you actually set up GeoAnalytics Server, and then any questions you may have. And of course, since this is a video, you can easily skip to the sections you want. Some sections will be very similar to previous years if you've seen the presentations because things have stayed fairly similar, but there will be new demos, of course, and new tools and a bit of reworking of the slides based on feedback from previous years. So with GeoAnalytics, and as with every GIS problem, the solution really starts with the problem you're interested in. And with GeoAnalytics specifically, it's often how do I make sense of large amounts of data? So this could be a huge CSV as we see on the left, a whole bunch of points in New York City. What can I actually do to make sense of this and bring intelligence and operational ideas to my team? So what is GeoAnalytics? GeoAnalytics parallelizes computing to quickly analyze large amounts of vector and tabular data. So specifically vector and tabular data, we're talking about points, lines, and polygons. Most often it is points because that seems to be the data that accumulates over time the most. But of course, lines, polygons, and tables are totally acceptable and things that we use in our inputs. And then parallelizes computing. So we are running across multiple cores, across multiple machines with GeoAnalytics Server. And all of that is baked into the tool. So you run a tool and it's going to distribute across the machines as needed. And it's a collection of analysis tools to identify patterns, relationships, anomalies, and incidents in large amounts of data across space and time. So really, we are providing a toolbox. To you, the end user, you see a toolbox. When it runs, it is doing this first paragraph. It's parallelizing the computing to quickly analyze the data. But for you, you're interested in the tools that you can use and how you can use them. One thing that's important is it matters across space. We are GIS users, so we understand the value of space, but time as well. So a lot of the accumulated data has a timestamp, so a lot of our tools we try and account for time. So that could be an instant or an interval in time, and we'll talk a bit about that later on in the analysis section. So why would you use GeoAnalytics? One is because your existing tools and workflows aren't processing your data fast enough. So maybe they aren't finishing or it's taking, multiple hours or days or weeks. Maybe your data is growing, so you expect that you're going to have a lot more data in the future. Maybe you're setting up new infrastructure now and you're getting ready to start analyzing that data in the future and planning, looking into GeoAnalytics and the capabilities and letting us know what capabilities you want in the future. That's really going to help. You need to distill your data into something more manageable to use in other analysis. Maybe you have a workflow you already need to do, but you're going to use GeoAnalytics to help prep for that workflow. You're going to find certain points, so you're going to aggregate into bins so that you can complete that other analysis. Or your data has a ton of noise and you want to explore it to bring out what's really important. So figuring out where those hotspots are, or figuring out a model based on all of that data. Determining, hey, what is the important information here that I need to extract and continue to build on and learn about. There is another one that I forgot to put here, but some of those tools are really cool. We have tools that are unique to GeoAnalytics that you just might want to use because they're available, something like reconstruct tracks or join features where you can do a spatiotemporal join. So GeoAnalytics leverages spatiotemporal analysis to answer questions like, using billions of emergency calls accumulated over the past decade, which counties have the largest number of calls per square mile? Which stationary pressure sensors in my pipe network have experienced anomalous events in the past 24 hours? And where are there hotspots of anomalous events? And where have my delivery trucks traveled, and where's the highest density of unique delivery truck paths? Where do delivery trucks travel the slowest? So there's two places right now that GeoAnalytics is available. So this presentation is current as of March 2020, we're talking about 10.8 and Pro 2.5. Those were the latest releases. So there's GeoAnalytics Server, which has been available since 10.5, and that's distributed processing across multiple server cores and machines with ArcGIS Enterprise. And there's GeoAnalytics Desktop. So this was a new product at 2.5. It's parallel processing, so you're just on a single machine on your laptop or desktop with ArcGIS Pro. So you install Pro, it's available if you have the advanced license. This presentation is specifically focused on GeoAnalytics Server. So the requirements are that you have Enterprise set up as well as a GeoAnalytics Server license. So why would you want to use one or the other? A few high-level points. Use GeoAnalytics Server when you want to bring big data analysis to your entire organization. So this is available through your server, which means everyone that has access to Enterprise that has the correct role is able to do this analysis. So it's not just one desktop machine with it, many people can access it. You can leverage the power of one or multiple server machines. So you can scale out to more machines than you can with the desktop version. You can connect to external big data storage and existing web layers, and we'll talk about this, but you can connect to something like cloud stores, HDFS, or any layers that you already have in your WebGIS. And you can extend custom analysis. So we have a way of running your own custom PySpark analysis on the Spark cluster set up with GeoAnalytics Server. And we'll have a slide on that as well, and we can link to some demos that are really interesting. GeoAnalytics Desktop is much easier to access. If you have Pro and an advanced license, you can go use it today. There's less setup, and it's really focused on processing local data, so from files or enterprise geodatabase or from your file geodatabase, and it's faster than before on your own desktop machine. The other idea is you could prototype workflows you want to use with GeoAnalytics Server. So maybe you want to try out GeoAnalytics Desktop tools, see if the tools fit for you, and then scale up to Server. I do think a lot of people will want to use GeoAnalytics Desktop tools. It's really nice to just, use that familiar workflow, work with the data that's local to your machine, and then if you find that you need to scale to your organization, that's when GeoAnalytics Server might come in. Because GeoAnalytics Server is server-based, it also ties in well with GeoEvent, whereas GeoAnalytics Desktop is more of a desktop workflow. Here is a quick table, and by quick I mean I'm going to skip over it quickly, but because it's a video you can easily pause and review it yourself. There's also a blog post that goes into this topic extensively, so I'm going to link to that. But just know that the motivations for choosing one or the other can depend on your input data, where you want the output to be, how you want to scale out the analysis, so one machine or 3 machines, the tools that are available. We don't have all of the tools in desktop that are available in server yet, and then as well as the interface where you actually do things. So GeoAnalytics Server, to actually access it, there are 4 different ways you can get to it. So the first is you can access GeoAnalytics Server in ArcGIS Pro. So this might seem a bit confusing. We have the GeoAnalytics Desktop tools, which run Spark on your Pro machine. And then we also have the GeoAnalytics server tools, which you can access in Pro and will run on your server machine. So that's just something to be aware of. When you're browsing to the tools, you'll be able to see where the toolboxes are. They'll be portal-based, and then you're just regular GP-based. But ArcGIS Pro is a way you can access the tools, which of course means you can access anything that you would use with ArcGIS Pro, like Model Builder or ArcPy. The other place is your enterprise portal. So in your map viewer, you can run the GeoAnalytics tools, and this is where Noah will probably be doing most of his demos. So this is a more simplified UI than Pro. The benefits of one or the other are usually just dependent on which you prefer. So if you're a desktop analyst and you like running in Pro, that's a great option. If you're someone who likes the online experience, a more simplified interactive UI, then maybe the enterprise portal is what you would choose. There's the ArcGIS API for Python. So all of these tools are wrapped up in the Python API, and you can access and run them in notebooks or run them in a standalone script with the API. And then the ArcGIS REST API. So this is one that I personally use a lot, but everything has a REST endpoint, so you can write your own custom web apps calling this API and running analysis as needed. So with that, I'm going to hand it over to Noah, and he is going to give us a quick demo.
Hey everyone, this is Noah with the GeoAnalytics team. Today I'm going to show you how to connect GeoAnalytics to your data and do some cool analysis with GeoAnalytics tools. So to get started, I have an S3 bucket here called Esri GA data with a few folders containing different data sets. So I have some that are made up of a single delimited file, such as this earthquakes dataset, and others that have multiple text files. GeoAnalytics makes it really easy to connect to wherever your big data is already stored, so that there's no need to spend time converting the data into, say, a feature service or loading it into a database before you do analysis. In this example, because all of these text files have the same schema, I can register this data set with my GeoAnalytics server, and when I run analysis later on, it will read through this data at the time of analysis, so that there's no need to move the data. It's just connecting directly to where the data is stored. So to do that, I'm going to go to my ArcGIS Server Manager application. You can see that I've registered this S3 bucket already as a Amazon Cloud Store. I'm just providing some credentials that will allow GeoAnalytics to connect to that. And then to create the connection that I mentioned before to that S3 bucket, I'm going to create a big data file share. And that's kind of the name for any connection to external data sources outside your WebGIS that we make for performing analysis in GeoAnalytics. So you'll see that there are a few types of file shares I can make, from a cloud store or a shared folder. I can also connect to HDFS or Hive. In this case, I'll choose Cloud Store, and you'll see that it's already chosen the one that I've registered. I'll name the file share the same thing, and then once I click Create, there's going to be a process running in the background of my GeoAnalytics server that will connect to this S3 bucket. I'll read through the first 20 rows of every data set in the bucket and try to determine the schema, whether or not there is geometry and time info, and things like the file type and whether or not there's a header, all that. And so this makes it easy. In a lot of cases, you won't have to go in and manually define, which fields are your geometry fields. If it's in a pretty common format, GeoAnalytics will discover that automatically. So after some amount of time, I can click the Edit button on that big data file share, and we'll see that it discovered 13 data sets. So like I said, in some cases, such as this earthquakes example, GeoAnalytics has discovered the schema of the data set correctly. It's found that it has point geometry info stored in an X field and a Y field. And it's also discovered that it has time info of type instant stored in a string field called datetime. So this is great. At this point, I'm ready to perform analysis on this earthquakes data set. But let's take a look at that Rio bus traces data set. We'll see that, in this case, those text files actually didn't have a header field, or a header row, sorry. So it's kind of represented each field name with these generic placeholder names. So luckily, using this UI, I can go in and edit this to correctly represent the data how I want it to be represented. So in this case, I know that column 1 is a date field, column 2 is the time, column 3 is the ID of all my buses, and so on and so forth. Most importantly, I know that column 5 is my latitude field, column 6 is longitude. So now I can set those fields as my geometry fields by clicking this drop-down. If I had polygon features, I could represent those in a string field using Esri JSON or GeoJSON. With points, however, I can choose 2 separate fields as my X and Y. So I'll choose longitude as X, latitude as Y. And I can also register time, since that's going to be really important in this analysis as well. So we'll provide a time zone of UTC. And GeoAnalytics is really flexible with how it lets you represent time in your data set. So here I'm going to register a date field, and I can provide a string that basically shows GeoAnalytics what to expect in terms of date formatting. So it shows here I'm telling it to expect a 2-digit month, -2-digit day, -4-digit year. I can even read times across multiple fields. So in this case, I have date stored in one field and time stored in another. And so for each feature, GeoAnalytics will use both of these fields and read it as one timestamp when performing analysis. So now that I've got this registered the way I want it, I can click Save, and I'm ready to begin. So like Sarah said, GeoAnalytics can be accessed through a few different clients. Today I'm going to use the Portal Map Viewer because it's really easy to access just through a web browser, and I use it a lot for testing, so I'm more used to it. But I could run this same analysis in a desktop application, ArcGIS Pro, or I could execute this analysis programmatically using the REST API or the ArcGIS API for Python. So, in all these cases, it's going to be the same analysis happening in the back end. So when I've already registered my big data file share, that data set of Rio bus traces is what I'm interested in looking at today. And one of the limitations of reading data directly from a source right when you run analysis is that I don't have this data loaded as a feature service to draw on the map here. And so to get a better idea and of to make sure that the data is registered correctly, I'm going to use the GeoAnalytics tool describe dataset. So with all of GeoAnalytics tools, big data file shares show up as really any other WebGIS layer. I can even filter by the item type, and here I see the Esri GA data bucket that I registered, and I can browse to the Rio bus traces dataset, and already we see that Portal sees it's a point dataset and it's time enabled. So I'll select that, and before I run the tool, what this is going to do is read through that dataset, generate some summary statistics on each field, and also give you the temporal extent, spatial extent, and then if you want a sample layer of a certain number of features to make sure that the dataset is registered correctly and that GeoAnalytics is reading it correctly. So I'll give this a new name. And click Run Analysis. And so right now this is sending out a request to my GeoAnalytics Server cluster, and all the analysis is being performed there. So in this case, I have 3 GeoAnalytics machines running, and all the cores on, or at least most of the cores on those 3 machines are being used to read through this data set. In the spirit of a developers conference, I'll show you what's happening behind the scenes. You can see Portal is actually making a request to my GeoAnalytics server. And if I click on it, I can see the REST endpoint of the job that's running. You can see from these job messages, there are distributed tasks that Spark, the engine that drives GeoAnalytics, is working through as it reads all the features in this data. And so once all those distributed tasks are completed, it'll write out a feature layer to my ArcGIS data store in this case, but I could also write results back to a big data file share if I wanted. So I could write back directly to that S3 bucket as well. And so once this job wraps up, we'll be able to see that we registered this data correctly and that we're ready to begin some more in-depth analysis. So pulling up the process information here, we'll see that the data set spans October 1st to October 30th, 2014, which is what we'd expect. There are about 115 million points here. And we can look at the summary statistics generated for each field. For example, these columns that I didn't change the name of are numeric, so we get average, min, max, etc. for each of those. And then we also get samples of each of the text fields as well. That sample layer of 100 features that we requested is really nice as well, because you can just see a few of the points on the map, click around, and make sure that they are what you'd expect. So now that I know the data is registered correctly, there's a few directions I could go. If I'm interested in just seeing where the data is, we often recommend users start with the aggregate points tool, which allows you to aggregate points into either your own polygon layer or a layer of square or hexagon bins that we generate on the fly for you. So in this example, because the job took about a minute, I won't run it now, but I aggregated those 117 million points into bins. And if I lower the up the transparency a bit here, you can see that we have some points in the ocean likely due to GPS error, but the highest counts of points occur in the city center as well as along the beaches and then out in these areas as well. So this is a good example of how to just quickly see, this just took a minute once again, where those 117 million points are spatially. I could also aggregate these across time and get a separate two-dimensional layer for each time step that I want. But today I want to show off a relatively new tool called Find Dwell Locations, which will basically allow me to find all the locations where buses have stalled for a certain amount of time. So in GeoAnalytics, a common theme to some of our tools is the idea of tracks. And a track is really any observation recorded over time. It could be moving like a bus or a plane, or it could be stationary like a sensor collecting measurements over time. But in each case, you have point measurements over time, and you need a way to tie together those point measurements so that GeoAnalytics knows which point measurements represent the same, physical object. And so here I'm going to select the ID of my buses to tie together those breadcrumbs basically into what we call tracks. So to find my bus dwells, I need to define a spatial search distance. This is the maximum distance a bus will travel to be considered a dwell in at least this amount of time. So I'll choose, let's say, 10 feet in at least 1 hour. So if a bus hasn't moved more than 10 feet in at least an hour, we'll consider that to be a dwell condition. There's a few ways I can choose to return dwells. I'm going to leave the default, which is the mean center of each dwell event. So we'll get 1 point for each case of a bus dwelling. And I can also choose to calculate statistics if I want. So just for fun, I'll calculate the mean of this numeric column. And if I clicked run analysis, once again, this would be sent to those 3 GeoAnalytics server machines I have running. But because this is a pretty computationally intensive operation, it took about half an hour to run through those 117 million points. And so I'll pull up the result that I generated earlier. You can see each of these blue locations represents a dwell in our data set. So now that I've filtered out this data set to only show where buses have dwelled, there's a few options with regards to how I can dive into this data and find patterns that I can act on. Now that this data set is more of a manageable size, I could bring it into a desktop application like ArcGIS Pro, or use external, for example, Python libraries to analyze the data. But GeoAnalytics also has a host of more spatial statistics-oriented tools that can be used to discover significance or other patterns in your data. So, these tools, some might look familiar, like calculate density or find hotspots, but they've all been rewritten to run parallelized across the cores of one or more server machines. So for example, I could use find hotspots, which I did earlier. It took a couple minutes to run on these dwell locations to see where there are statistically significant areas of bus dwells when compared to their neighbors. So in this case, we see that these red areas represent 99% confidence that those are hotspots of bus dwells that we could then investigate and take action on if we wanted to, if they're unexpected and we wanted to improve bus service there. But as you saw, there's a lot of other tools here to explore. For example, the Find Point Clusters tool, we recently added a spatiotemporal clustering algorithm to, which was shown in the plenary session in the GeoAnalytics Server demo. So I recommend you go check that out because we won't have time to look at it here. But there's a lot of capability here to dive into, and so we recommend you go check out the list of tools that are available in GeoAnalytics Server using the resources we'll share, and see what tools might be applicable to your data. And if there's any workflows that aren't supported, we'd love to hear about those, and what we could add to this host of tools to make it what you need to process your big data. So with that, I'll hand it back to Sarah to discuss more about our analysis capabilities.
Awesome. Thank you so much, Noah. That was a great example of running the analysis in the Map Viewer, as we discussed just in the previous UIs. So with that, I want to go into more of the analysis capabilities and the tools that we actually have available in GeoAnalytics Server. So I've just denoted something with a cross that if it's new at 10.8, we have one tool plus a kind of special edition, which I'll mention. So the GeoAnalytics tools are broken up into tool sets to help you understand what the tools do. So summarized data is really about visualizing and summarizing what your data actually looks like. So it's more easy to describe with an example. Aggregate points, for example. You have a bunch of points and you want to aggregate them into bins so you can more easily visualize all of those points. We do have a few tools unique to GeoAnalytics, build multivariable grid, for example, which I'll mention later, and describe dataset, which just gives an overall summary of your dataset, which is really helpful when it's too big to open in something like a CSV, or you just have a hard time understanding it. Join features I'll talk about later, but all of these tools are really powerful and usually the place you're going to start when you use GeoAnalytics. Analyzing patterns are your more statistical-based tools, and this is the one where I have that star, so find point clusters. At previous releases, we had finding point clusters just based on location. We've now added a spatiotemporal algorithm as well, so that was added at 10.8, so you can find point clusters in space and time, and I'll link to a video and a blog post kind of outlining an example of that. Find locations. These ones are usually fairly unique to GeoAnalytics, and then also include something like geocode locations, where we're using your geocoder that you've already set up. Find dwell locations is a new tool, and we are going to link to another place where you can see that. I don't want to say we have so many links, but I really want to give you the resources you can do to find what you're interested in after this presentation. Use proximity has create buffers. Data enrichment, you can enrich from the multivariable grid that you can build with summarized data, and I'll walk through that in a few slides. And then manage data. So these aren't so much management as more basic GIS tools. So appending data, calculating a new field, copying them around to different data stores if you need, dissolve, merge, and overlay. Yeah, more of those GIS tools you're probably familiar with in your intro to GIS type class. So the capabilities, a lot of them work with both space and time. Not all of them, and usually time is optional. There's some tools, the track analysis tools, that do require time, but GeoAnalytics tools are meant to perform spatiotemporal analysis. So when you have an input, you need to define your temporal input by either instants or intervals. So an instant is a single moment in time, whereas an interval has a start and end. Instants seem to be most popular, especially with event data. An Uber pickup happened at this location and this exact time, but there are intervals as well for a ride, for example, if you had a start and end time. You can analyze data in time steps, which you can see over on the right. This is lightning strikes. We've aggregated them into bins and we're looking as the time changes. Imagine there was a time slider going at the same time. This is available in a few tools like aggregate points and calculate density, find hotspots, and create space-time cube. And then of course, when you have temporal results, it's really helpful to visualize them in both Pro and Map Viewer, where they both have time sliders and capabilities to choose what you actually want to visualize and if you want to drill into specific time steps. For the analyzing the data in time steps, I'm going to link to something that will point to Doc to talk more about this. This is something that's really cool, but we unfortunately don't have time in this presentation to dig into it. So join features is, in my opinion, our most powerful tool. A lot can be built on top of this tool. It allows you to join data by location, time, and attributes. So you could just do a join by location, so that would be very similar to a spatial join tool, point and polygon, but you could optionally do just time, just attributes, or any combination of those. So you could do a location, time, and attribute join all at once. I have two kind of examples here. I have the A workflow right on the top, where we have a polygon data set and a point data set. The polygon represents an interval in time, and each polygon has its own interval, and then the points have an instant. You can see we're joining the points to the polygons, and we're getting the resulting points within the time and location of the polygons. The other is just the opposite to show that all of these relationships flip, point, polygon, line, any order to be the target or the join layer. And then the time relationships, I think there's 13 different relationships. This is obviously the most simple to understand, the point or the instant within an interval, but there's near after, this point happened within 10 minutes of another point. There's many, many relationships you can do, which makes it super powerful for your analysis. Reconstruct tracks is something I want to call out as well. So this was our first track-based tool. Tracks are a object moving through time, so with some kind of ID. You can see on the left diagram, there is the blue track and the purple track, and when we reconstruct them, they are now lines, basically. The common example we give is hurricanes, because that's easy to understand and visualize the tracks of hurricanes. We've since expanded to a lot more track tools. I believe we have at least 4 now. We have reconstruct tracks, detect incidents, find dwell locations, and calculate field, which allows for track expressions as well. So these are something that I've highlighted in my Pro presentation, and the exact same concepts apply here, so I will link to that as well. Examples, as I said, are hurricanes, ships, and airplanes. And here is a hurricane diagram on the right. A tool that's unique to GeoAnalytics Server and is not yet available in Pro is the Build Multivariable Grid tool. So you can aggregate multiple data sets into one. So this is really powerful when you have all of these disparate data sets. You have a bunch of parks and you have some fire hydrants, and they're all over the place, and you want one data set to represent all of those. And it's not just representing the data sets, but it's representing relationships with them. So you can calculate any of these attributes on those data sets. So the distance to the nearest, you calculate the distance to the nearest park, the attribute of the nearest park, so maybe the name of the park, the summary of intersecting, and the summary within a given distance. So you can do this on one or more layers of interest. So you can do as many combinations as you want for this analysis. You can then use this layer for visualization, which is totally a great representation of what you're doing, and that could be your final step here. But you could also use it to input statistical tools like GLR or forest-based classification and regression, or as an enrichment layer. So you create this multivariable grid, and then you enrich a point data set with it, which would be similar to a join. So you're adding all of those attributes. This might not make sense yet until we look at a visualization of what we're doing. So this is what a grid would look like of the nearest subway station, for example. So we have the red dots for each subway station, and the grid result would be the distance to the nearest one. This is the nearest park. And again, the red would be the park, so the results would just be this grid. And we have the population per square mile and the number of complaints. So each of these calculations would be a different field in the resulting data set. So you could switch between what you want to view based on those the fields. This one is really powerful for visualization, as I said. And the more you think about all of those data sets you kind of want to pull together, the more helpful this tool will really become. Something that's also unique to GeoAnalytics Server is the ability to access and use PySpark. So this is a way that you can run distributed Spark analysis on your own GeoAnalytics server without having to set up your own Spark cluster, basically. That's the really big benefit. And to do this, you run a tool called Run Python script. So this is available through REST and the ArcGIS API for Python. And it means you can run the custom Python script on your GeoAnalytics server site, use other Python functionality, and distribute analysis across your site. So other Python functionality means you can chain GeoAnalytics tools together, you can pipeline GeoAnalytics tools together, but you can also use PySpark like SparkML and SparkSQL. I mentioned that you can chain them together. One of the big benefits of chaining tools together is you don't need to write any intermediate outputs. You could chain 3 GeoAnalytics tools together and get one single result. There's no need to get those 2 intermediate results and then the final result. And then, as I mentioned, you can use PySpark, SparkML, and SparkSQL, and data frames. So everything will be represented as a data frame. So whatever you can do in PySpark with data frames, you can do that here with these tools. And again, it will just use your server, your Spark cluster already set up with GeoAnalytics Server. This is very, very powerful to start writing your own custom analysis, to start speeding up analysis by chaining. And this really is a great developer story and an intro to Spark if you haven't already been using it. And with that, I'm going to hand it back over to Noah for demo number 2.
So I'm going to switch over to ArcGIS Pro for this demo. I'm signed into my ArcGIS Enterprise, which is the same enterprise I was using earlier to run analysis in Portal. Because I'm logged in, I should have access to those same GeoAnalytics tools I was just showing you. The UI should look more like a Pro UI, but when I click run in any of these cases, it's going to once again send requests to those 3 GeoAnalytics server machines I have running to perform the analysis. So nothing's going to be happening on my desktop machine. Now with notebooks in ArcGIS Pro, you can easily use GeoAnalytics tools programmatically. You could before in the Python window as well, but now we just have this notebook environment to work with, which is pretty nice. So using this environment, I'm going to show you an example of the Run Python script tool, which, as Sarah mentioned, is only available through the REST API or the ArcGIS API for Python. And so in this case, I'm going to be using the ArcGIS API for Python. As you can see, I connect to my GIS, which is just that enterprise instance. Should be pretty familiar if you've used the API before. But then what's unique to this tool is that we're actually going to be passing a Python script to our GeoAnalytics server, and that Python script will be run in the Python environment that comes with my GeoAnalytics server cluster. The reason we want to do this is because it exposes PySpark, which is the API for Spark, which is the engine that drives GeoAnalytics tools and distributes analysis across multiple cores and machines. So what we've done is really included the PySpark API as well as a few additional things that we've implemented on top of the API to make it seamless with WebGIS or your ArcGIS Enterprise. As an example, you're able to read in WebGIS layers with one line of code into a Spark data frame. And if you're not familiar with Spark data frames, it's a similar concept to Pandas data frames, except this is really built to be distributed across multiple cores and machines for fast processing. So here I'm loading, I'm just going to duplicate that exact same workflow that I showed you in the last demo, but going to do it in Run Python script so that we don't get any intermediate outputs. The reason that is because once I load for example, the Rio bus traces big data file share into a Spark data frame, it's going to be represented by this bus traces variable. So I can pass that as an input layer to the find dwell locations function, which is exposed in PySpark as well. And the result of that tool will be another data frame. So I can continue passing the result data frame to another tool and chain tools together. Nothing will be written permanently to a data store. It will all be done in memory until I explicitly call .write on a data frame. In this case, I can specify the format WebGIS, but you can really write to any format that Spark supports. And then I just need to give it an output name. So I ran this earlier, and the Python API gives you some nice messages to look at. And the result is written out as a feature service, so I can actually just browse to it and bring it into the map right away. Let me find that layer here. And because there's no default symbology with this tool, I'll go to symbology and symbolize on the, let's see here, symbolize on the z-score value or the bin. And we see we get the same result that I showed you in Portal earlier, except this time we don't get that intermediate layer of dwell results. And I've also added a step of clipping the result to the boundary of Brazil so that we get a nice output with no bins in the ocean. So this is an example of how you can pipeline GeoAnalytics tools. As you can imagine, this can get pretty complex. This all ran as one tool, as you can see here. which is really great for automation and creating exactly the analysis you want without all these intermediate layers. But another nice thing about PySpark is that because it's exposed in this processing environment, you also get access to all of the PySpark ML libraries. For example, in this script, I'm using k-means, which is not a GeoAnalytics tool, that's a Spark ML tool. And I'm going to use it to find clusters of earthquakes. This is that data set I showed you in S3 in the first demo throughout the world. So this is kind of an arbitrary or contrived example, but we're going to find 50 clusters of earthquakes using their latitudes and longitudes. And we're just going to write this out to a feature service. So because it's just a data frame, Spark tools also create Spark data frames. And so we can write those out just as if we had been processing using GeoAnalytics tools. So let me run this quick since it doesn't take too long. I'll connect to my GIS. Oh, give it the wrong password. You see that we're connected correctly. I'll load in this script as a variable. And then all I need to do is run the tool. So this will be processing in the background, and then once it's finished, all those messages will be returned to the ArcGIS notebook. So we get an error that the features field is not supported, and that's because it's I assembled it into a vector type that is unique to PySpark but not supported in the ArcGIS data store, so that's fine. It's just a warning. And so once the tool completes, we'll see it took about 41 seconds. And once again, I can go over to the map. I could draw this in the notebook itself if I wanted to, but just do this for simplicity. So I can pull up those earthquakes. Results written to the spatiotemporal data store will have binning enabled by default, just in case there's a lot of features to draw. So I'll remove those, and then we can symbolize on the cluster prediction field that was generated by the PySpark tool. I'll use unique values instead of graduated colors. And so you can see the algorithm has prediction. The algorithm has clustered these earthquakes based on location into 50 different clusters of about equal size. So once again, kind of a contrived example, but it shows you how you can leverage PySpark ML libraries as in your WebGIS pretty natively using the Run Python script tool. So if you want more information on this, I would recommend checking out this blog. If you just Google that title, you'll find it pretty easily. But this is kind of a jumping off point for using Run Python script and links to a lot of great resources, including some more example code and a GitHub repo with some more examples as well. So with that, I'll hand it back to Sarah to wrap up the presentation and talk more about deployment.
Thank you, Noah. So next up, we are going to look at data integration. So one of the benefits of Server over desktop, as we mentioned, was a lot of the data sources that we can connect to. So what types of data can you actually analyze and from where? So you can access and share data within Enterprise with your Enterprise portal. So if you have a web GIS layer, a feature layer, a map service layer, you can use those as inputs to your analysis as well as outputs, so you can share your results through Enterprise. You can analyze data collected with ArcGIS GeoEvent Server. So if you're familiar with GeoEvent Server, you might be really excited that they use the spatiotemporal data store to expose a feature service. We can easily use those stream services and feature services as input to our tools. And because we work together, they write directly to the data source, we read directly from the data source as well, which is cool and makes it much faster. Here's something that's unique across the platform is we can analyze data in Hive, HDFS, and files. So you're able to connect to a shared location, HDFS location, Hive, and we're able to read that as input based on something what we call a big data file share, which I'll talk about before, and Noah will demo as well. And then lastly, you can connect to Azure and Amazon cloud stores. So you can register a cloud store and read that in as a big data file share. So you could have a whole bunch of CSVs, sitting up in your Azure blob store, and we can use that as input to the tools. We can also write that back as results. So if the rest of your company does not want to look at a GIS layer, which is shocking to us, but there are people out there that maybe just want a CSV output, you can write your results back to those cloud stores. So let's talk about big data file shares. Big data file shares are not a requirement to use GeoAnalytics. You could just use feature service layers and that would totally be fine. But they are something that's very powerful, and most people do use them because they're really interested in accessing the data that big data file shares can access. So big data file shares can read directly from files stored in Hive, HDFS, shared folders, and cloud stores. The supported file types, so within those locations, they could be delimited files. This could be CSV, text files, shape files, ORC, and Parquet. And one really big benefit of GeoAnalytics is that we can use multiple files with a matching schema in a single data set. So here I have a folder called Lightning, and the way big data file shares work is this would be a data set called Lightning, and all 12 shapefiles within it would be represented as that single data set. So if I browse to a tool, said, hey, I want to use the Lightning big data file share data set, all 12 shapefiles are going to be used in that analysis. Because we know that with big data, you're accumulating it over time. So in this one, for example, we know there's 12 there. I would assume each one represents a month. An analyst got 1 month in at a time, created a new shapefile each time. This is also nice because we know there's that limitation for shapefiles that have 2 gigs, so you can partition your data and quickly read it in. We do find that big data file shares are one of the fastest ways for us to read data in, so it is a really great thing to use if you've been struggling to get your data ingested, and you can just totally avoid that step of, the first time an analyst would see this, they would say, oh, okay, now I have to combine this all into one data set. You don't need to do that. You can just use it as is. As much as possible, we want to be able to use your data as it is. And if you find that you have data that you can't use, we really want to know about it. We're going to give you our contact email later because we always want to be working on adding new data set types and flexibility. One thing I didn't mention here is that big data file shares, and I believe Noah will show in the demo, are very flexible in the time and geometry formats. So we know it's important to work with your data as it is, as I said. So you could have fields that were X and Y, and we can just say, hey, that's the X field, that's the Y field, that's what's representing geometry. You could have a field in WKT that was a polygon, and we can read that in. You could have time across multiple fields, for example. You could have a field that represents the year, a field that represents the month, another field that represents the day, hour, minute, second, etc. You can format all of those fields to be represented as the time. So when the analysis is run, time is treated as a first-class citizen, and we say, hey, these 6 fields represent time, use that in the input, and we know that time is being used on that feature on the input tool. So that's something that's really cool and powerful about the big data file shares. Something that we added in the last year or so at 10.7 was the ability to write back to big data file shares. And I mentioned this earlier, a lot of this motivation is because, hey, maybe analysts, don't want to write a feature service, they just want to write back to a big data file share. A con of the big data file share, of course, is because it's stored somewhere else, you can't visualize it on a map. So I think a lot of people are going to use, big data file share as input, run their analysis, and then they're going to finalize their analysis. Once they're okay with the results, they're like, hey, this WebGIS layer looks as expected. They might output it back somewhere else, like Amazon S3 for other team members. And the formats there would be the same as the inputs. So it would be ORC, Parquet, delimited files, or shape files. So how do you actually use those data sources? In Server Manager, you're going to browse and add a big data file share, specify the path, and then you're going to register it. When you hit Create, and see there's many types. When you hit Create, we're going and we're querying that data. So we're looking at the data, we do a sample, and we're doing a best guess of what that data set actually looks like. So that's when we say, like, hey, these fields probably represent geometry, or these fields probably represent time. If we're wrong, you can easily change it in Server Manager. But most of the time, we've done pretty good work trying to identify those fields, so we will get you most of the way there for most data sets. And here I had 45 data sets. You can see it's representing the fields, the geometry, the time based on the time field name, ISO time, for example. There's something called a manifest, which is a JSON representing that. So that's how you actually use those data sources or how you register them. And then when you're using a tool, you're just going to browse to them. So let's talk a bit about deploying GeoAnalytics Server. So this is something that can seem really daunting at first. It's part of ArcGIS Enterprise, so if you have installed a base deployment before, this is going to be a walk in the park to set up GeoAnalytics Server because it's just the exact same components. So what do I actually mean by that? So what do I need to install to use ArcGIS GeoAnalytics Server? You need Portal for ArcGIS, you need ArcGIS Server, ArcGIS Web Adapter, and ArcGIS Data Store. So all four of these components are the exact same things you would need for a base deployment. You're just going to do additional installs of them. For ArcGIS Data Store, you don't need a spatiotemporal for your base deployment, so that is an extra data store install, but it's just a different button when you're configuring the data store to select spatiotemporal over relational. So when we set up GeoAnalytics sites, we currently have two recommendations, or two recommended site sizes. The first is a single GeoAnalytics server site. So on my left, I have my base deployment. So this is a prerequisite to set up. If you're setting up Enterprise for the first time, you will definitely start with the base deployment, get that working, and then work on the two circular items on the right. So again, on the left, you have the web adapter for your portal, you have the portal itself, server and its web adapter, and the data store. On the right, this is where we're talking about the one machine site. You have a single install of the ArcGIS GeoAnalytics server site with the web adapter and a spatiotemporal data store. You also have the three machine site, very similar, except instead of just having one machine, the server site for GeoAnalytics has three machines. So you install one machine, you install two more and join the site of the first one. For the data store, you would install three and configure all of them with the hosting server. The data store is always configured with the hosting server because it hosts your data. So steps to actually install this. So the first one, of course, is your base deployment. This is going to be the same no matter what. The next part is when you actually start getting into the GeoAnalytics bit. So the second bit is to set up your GeoAnalytics server. When you are installing GeoAnalytics Server, it is just an ArcGIS Server install. There is nothing special until you say, I'm going to license it as a GeoAnalytics Server license instead of a GIS license. You set up the web adapter and then you federate it with your portal. So everything in step 2 is the exact same as what you would do with your initial GIS server, except the license file is different. Then you're going to install ArcGIS Data Store and configure the spatiotemporal data store with your hosting server. So the exact same thing you did with the relational ArcGIS Data Store on your base deployment, except you specify the spatiotemporal data store. The next step is to set your GeoAnalytics server as your GeoAnalytics server. So if you're in Portal, you're going to go to Server Settings. You've already added that server, and there's just going to be a drop-down to specify which server is used as your GeoAnalytics server. This UI, I think, is changing in the next release or so, or might already have been modified. So just a heads up, if you're looking at this and have a newer version, it will be generally the same. You're still going to go to Organizational Settings, Servers, but it might just not have those exact same images. So just be aware of that. When you actually do that, when you've set the GeoAnalytics server on that settings page, that's when your GeoAnalytics tools are going to become available. So you can go to the Map Viewer and you'll see those tools. Until then, you will not see the tools anywhere, and you won't have the option to register a big data file share. You need to wait until it has actually been picked as your GeoAnalytics server. So as for the system requirements, as I mentioned, there's the base ArcGIS Enterprise deployment, and this will be the same requirements that you normally have for the base deployment. So a minimum of 4 cores and 16 gigs of RAM. There's the ArcGIS Spatiotemporal Big Data Store, so minimum of 16 gigs of RAM for each machine, and we really recommend that you do up this to 32 gigs if required. It is memory intensive, you're distributing the data across multiple machines. The more RAM here, the better. We also recommend fast disk and sufficient disk space for data. And then here is a GeoAnalytics specific recommendation. You want at least the same number of machines as your GeoAnalytics server. So if you have 3 GeoAnalytics server machines, you need to have at least 3 spatiotemporal big data machines. You can have more spatiotemporal big data machines, but you should have the same number or more, not less. And then, of course, the ArcGIS GeoAnalytics server. So you should have 1 or 3 machines at this time. We want a minimum of 4 cores and 16 gigs of RAM for each machine. You also want sufficient temp space for the compute. So if you run out of RAM or memory, everything will overflow to disk, so you do want to make sure you have enough temp space for that. If you want to get bigger machines, I would recommend that you up from 16 gigs to 32 before upping the cores. That does seem to really improve the requirements or improve the performance. As for actually deploying ArcGIS GeoAnalytics Server, it's compatible with both Windows and Linux, just like ArcGIS Enterprise, and it can be deployed on premises or in the cloud. So that will be up to your organization, what you already have configured. On premises, of course, it would only be available to your team or to your company. If it's in the cloud, you can have a publicly available portal, and that would be Amazon or Azure. We do recommend you simplify the deployment. It looks easy in those diagrams. It is easy if everything goes right, but we all know that everything will not always go right. So I think as much as possible, help yourself. And you can do that with things like ArcGIS Enterprise Builder. This will install that whole base deployment for you, and then you can build out on that if that's what you're interested in. You can also use Chef cookbooks for ArcGIS, so multi-machine and HA deployments. That would be helpful. And then if you're using Amazon or Azure, definitely use the Enterprise Cloud Builder. This will set up things for you easy peasy. You won't need to deal with any of permissions or figuring out if machines can connect to each other. We definitely recommend use ArcGIS Enterprise Cloud Builder. We see multiple issues if people are not using it. And it's very hard to troubleshoot those issues. So please try and use that if possible. So in summary for this presentation, GeoAnalytics is integrated. It works with your existing big data storage and your existing GIS data or what you currently use. So desktop or enterprise. It's going to work with what you have, and you're pretty flexible in how you use it. It's spatiotemporal. So tools are designed to analyze data in both space and time. You don't need to have a time component on your data to use these tools, but a lot of the tools can use it if you have it. Track tools definitely require it, but we find most people have it, and we've really accounted for that. It's accelerated. It speeds up analytical processing time using built-in parallel compute. So there's no work that you need to do to parallelize anything, to get Spark running. It's just working as is with whatever data set you provide. And lastly, it's actionable. So you're able to crunch through large volumes of data to generate actionable insights and intelligence. And this enables you and your organization to visualize and react to large amounts of data in a clearer and more meaningful way. With that, I have some helpful links. I know that you cannot click on these links, so I'm really going to make sure that they are in the description, and if not, I will comment below. But we do have a few blog posts that have recently gone out that will be really helpful. So if you're Googling any of these terms, you should be able to find our presentations. And then we also have our core documentation as well as plenary videos that will give you a nice overview. If you have any questions, I know because this wasn't live, maybe you're watching this and have questions, please email us at geoanalytics-PEs. PEs is for product engineers. That's the role we play on our team at Esri.com. And with that, thank you so much for your time. This was great. Thank you.